Okay, calculations related to Newton's second law. I told you that Newton's second law was the math law, and it's the one where we do most of the calculations. So please write down, I have I think 3 examples or so. Please write down the example. I'm going to jump to the solution. If you pause while you write down the example, and I'm going to jump ahead. Okay, so this question is asking us to find the net force if we have a mass of 1,500 kilograms and it's accelerating at 2 meters per second squared. And this question is as easy as it looks, okay? It's just F net equals ma, multiply, you get an answer in newtons. It's hard to say with something like, net force, is this a good answer or not? Like, what does 3,000 newtons mean? I'm putting a check mark on it just because I know the numbers make sense, right? But what would be a good indicator to you? And I guess one thing you could say, the one way I can picture force is this, that if you held something that was a kilogram, and I guess it might be maybe about a textbook, hold it in your hand. What you're feeling in your hand is 10 newtons down when you hold 1 kilogram, 9.8 newtons. So 1 kilogram is 10 newtons weight, right? And it's the same idea. So we're looking at 3,000 newtons. Well, is that a reasonable amount to push a net force on a car that's accelerating? Probably, right? If 10 newtons is 1 kilogram, right? It's hard to get a good handle on that, but that's one way I think of it. Second example, please go ahead and write it down. This time we have a small little tennis ball, 150 grams, and we know its net force. And so we want to find its acceleration. Please write down the example, pause to get the example down, and I'll move ahead. So in this case, to solve for that, you should have that example written down. It is 2 steps in this solution, because the first thing you have to do is you can't use grams. You have to use kilograms. Okay, so a little, something that if you didn't know before, you should know now. If you're given grams and you need kilograms, you divide by 1,000. So taking 150, dividing it by 1,000, you end up with 0.15 kilograms. Okay. F net, we're looking for acceleration. It's just a straight divide, 5 meters per second squared, and I'm going to check mark that because, as I told you before, a good acceleration is generally between minus 10 and 10. Not always, but generally. Okay. I suppose I should have added to my solution that the acceleration is east. Put that on my answer. I'm terrible at writing with this, but oopsie. Okay? Because acceleration does have direction. All right, that was pathetic. All right, next. Peter. Okay, this is a more complicated one. Last example. He accelerates when he applies a forward pedaling force of 500 newtons against a wind and road resistance of 350 newtons. If the combined mass of Peter and his bike is 125 kilograms, find his acceleration. So this one is a much more complicated question. It does involve 2 steps. And please write it down, and then here comes the solution. Pause, please, while you write down the question. And here's the solution. 2 steps. First, we need to find his net force. Then you can use Newton's second law. And the way that I know that that's what you do is it gives me 2 forces. So I know that, how do I know which is his net force I'd use in the F net equals ma? Well, if you're given 2 forces, that's an indicator that you're going to have to use a free body diagram to find net force. Okay? But you're not going to be able to straight jump into net force equals mass times acceleration. Okay? So here we go. In the first step then, I draw my free body diagram saying he's moving in this direction. That's his pedaling force. And here's his wind resistance, air resistance, and road resistance. Resistance is always opposing motion. So I can find his net force, forward minus back. Okay? And then in step 2, I can use the acceleration formula. F net divided by m. Okay? And again, I seem to have an answer that's reasonable, between minus 10 and 10. So I'm going to check mark it. Okay, so that was the tough one. If you have any questions about that one, I can help you out in class, but otherwise that's it for Newton's second law calculations. If you found those tough, I do suggest you practice a few. Do that for your assignment. Choose some of the questions for your assignment.